The range of our trig functions depends upon which trig functions we're looking at, and I think it's easiest to look at this when we compare their graphs. So here I've graphed for you both sine and cosine, our sine and cosine functions. Sine is the function in red, cosine is the function in green. And if you notice, based on this function, range is going to be the possible outcome values, or my possible y values. Notice that the possible y values for both sine and cosine bounce back and forth between negative and positive 1. So I've got a negative 1 down here, I peak at positive 1, same thing for sine, negative 1 peaking at positive 1. And I can include both negative and positive 1 on these functions. So if we're talking range, then we're talking possible y values, and so the range of both sine and cosine is from negative to positive 1. What about tangent and cotangent? Tangent and cotangent I graphed for you here as well. When I graph these, ignore these vertical lines that are showing up here, because really the tangent function is this, looks like a squiggle. It also reminds me kind of a cubic function, okay, and it's going to repeat here. It repeats, and the cotangent function would be the same type of shape, except it's going to decrease. It looks like the inverse of our cubic function. And again, if we're talking about possible y values, notice that my function comes all the way from the negative and goes off into the positive for y. And that's the same for cotangent and tangent. So for the range of tangent and cotangent, we're looking at negative to positive values with the parentheses, because I cannot ever include the end of infinity. So we've looked at sine, cosine, tangent, cotangent. Now let's talk secant and cosecant. Notice I had to put these functions in differently with what I was looking at, because I know that secant's inverse is 1 over sine, I could graph it, and cosecant's inverse is 1 over cosine. I was able to graph it on this applet I used. Now, there's a lot to look at here. The part you want to kind of look at is each of these parabolas. Okay? Ignore again the vertical bars, they're showing up because of asymptotes. But the function in blue is going to be cosecant, the graph of cosecant, and the function in pink or purple is going to be cosecant. So notice that as my function, right, the range, the possible y values are going to dip down to positive 1 and go back up to infinity, or they're going to come up and hit negative 1 and go back down. Okay, so as my function moves along, it's going to go like that, and then it changes and changes, and it just alternates like that for both cosecant and secant. So if we were to write this out, we could say then that from for the smaller side, we would have from negative infinity to negative 1 bracket, and then union that with 1 to positive infinity. Again, these are the possible y values, or in other words, the range of my functions. So I can kind of summarize that here, which I did. This is the range of my trig functions. For sine and cosine, it's from negative to positive 1. Tangent and cotangent, it's negative to positive infinity. And secant and cosecant are this right here. Let's use that information then to look at examples together. The first example is just how well do you understand what we just talked about. If I gave you cotangent of theta was equal to negative 0.999, is that possible? So if the cotangent of theta is negative 0.999, is that a possible value? Well, I'm going to scroll back up here and let you look at these ranges again to look at that. Cotangent is between negative and positive infinity, and negative 0.999 would definitely fall within that value. So the answer to this would be yes, and that's because the range for this is from negative to positive infinity. How about the cosine theta of negative 1.7? Is that a valid answer? Well, cosine's range is only from positive to negative 1. This lies outside of that range because that's more than negative 1, and therefore that answer would be no, because we can only go from negative to positive 1. And finally, the cosecant of theta is equal to 0. Is that a valid answer? So scrolling over here, looking at cosecant of theta, cosecant goes from negative infinity to negative 1, and then jumps again from 1 to infinity. It does not include the value 0, so we could answer that as no.